Assalamualaikum warahmatullahi wabarakatuh. In this video, we will explain about our power electronic uh, power electronic assignment project, which is the title is three-phase inverter system. Okay, my name Ahmad Amirul Ashraf bin Osman and my number matric is AE200001. Okay, first I will explain about the introduction. As we know nowadays, most of the applications and machine in this world work based on AC power. So in this modern world, that we can convert DC power to the AC power. This type of conversion from DC power to AC power is done by power electronic device called inverter. Inverter do the opposite of rectifier, which were originally large electromechanical device converting AC to DC. So we have three type of inverter, which is current source inverter (CSI), voltage source inverter (VSI), and current regulated inverter. So then three-phase inverter is a device that convert the DC power to three-phase AC power. They are frequently employed in high power and variable frequency transmission application, such as HVDC power transmission. Three-phase inverter is a single-phase bridge circuit extension. Okay.
Hello, my name is Muhammad Shazmin Shah bin Ishaq. Matric number AE200007. I'm going to present to you about calculation. So the inverter has 8 switch state given in the first table as explained earlier in order that the circuit satisfy the KVL and the KCL. Both are switched in the same leg cannot be turned on at the same time as it would short the input voltage violating the KVL. Thus, the nature of the two switches in the same leg is complementary. Okay, in accordance to the three-phase full bridge inverter. Okay, this of the 8 switches state as shown in the first table, two of them produce zero AC line voltage at the output. In this case, the AC line current free wheel through either the upper or lower component. The remaining state will produce no zero AC output line voltage in order to generate a given voltage waveform. The inverter switch from the state to another, thus the resulting AC output line voltage consists of discrete value of voltage which are negative VDC 0 and VDC. Okay, the selection of the state in order to generate the given waveform is done by a modulation technique that ensure the use only the valid state. Okay, the second table show uh, the result of our calculation, which are we add the input number from input number which is 1000 VDC. So that's all from me. Thank you.
Okay, for the methodology, as we can see in the diagram, in our project, we use the SPMW three-phase inverter circuit. So, all three single-phase inverter are doing is being connected to the same DC supply. The three-phase inverter pole voltage are identical to a single-phase half-bridge inverter pole voltage. The switches of basic source voltage inverter can be activated and deactivated as necessary. So for the SPMW circuit simulation, we design in the MATLAB Simulink.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Ihsan Wisham, AE 2032. Today I'm going to present about the design of this three-phase system inverter. Okay, firstly we have sawtooth generator here, and we have three sine wave, and then we have the scope here. Then after we run, we can get the answer. Okay, this at the scope. Okay, after that, at the scope here, we can see also the answer after we run the skirt. Okay, here is the answer that we can get here. For sine wave. Okay, to that we go to the three-phase SPWM inverter. Here we have IGBT diode. We have 6 IGBT diode.
and here we have switch, 6 switch, and then here we have the DC voltage source, which is 1000 volt. Okay, here we have inductor which is 5 millihenry, 15 millihenry, and then here we have the capacitor with 20 20 microfarad, and here is the three-phase voltage current measurement. And then we go to the scope. At the scope, this is the voltage scope if we want to measure the voltage. Okay, here after we run the circuit, we get this answer. Yeah. Okay, after that this is the current. If we want to measure the current, we press this, then we get the answer here. Okay, that's all.
Assalamualaikum, I am Wan Raziman, matric number AE20030. I will explain about the result and discussion. So this is our three-phase SPWM inverter circuit that convert the DC to the AC. So the result for the first scope, the waveform for the first scope shown the carrier wave, the sawtooth wave, and the sine wave is the reference wave for the VA, VB, and VC. Next, the second scope. Next, the second scope. This is the second scope. The result we get this, the sawtooth and sinusoidal wave, and this is the square wave for the switching. Next, for the voltage and current. For the voltage wave, we got sinusoidal voltage wave, but not too smooth. And the max, the V peak is about 511 volt. Next, for the current, we also got the sine wave, but not too smooth, with the V peaks maximum 36 ampere. So this is the LC filter that functioning to lower the THD and make the waveform for the voltage and current become smoother. So for the THD, we use FFT analyzer, and for the voltage, for the load voltage with fundamental frequency 50 Hz, we got THD 6.67%. And for the current, with fundamental 50 Hz frequency, we got 6.8%. So we got so the THD for the voltage and current, we got less than 7%. That's all.
Yeah, Assalamualaikum. Thank you for the presenter before me. So, my name is Muhammad Faiman. So, I would like to continue with the conclusion. As a conclusion, we managed to solve an open-ended problem and find the relationship between the knowledge learned in class for three-phase inverter system. A power electronic device known as an inverter is used to convert the three-phase electricity from DC to AC at the required frequency and voltage output. This can be categorized based on the supply source and any associated 6-switch inverter topology in the power circuit. The 6 switches are included in a basic 3-phase inverter, and each switch can be linked to a load terminal. We also get more knowledge in analyzing a power electronic converter based on certain requirements using an appropriate simulation tools, and are able to solve the issues or problems encountered. We also learn about the LC filter that used in the circuit to lower the THD of the output voltage and current and smoother the sinusoidal output waveform. Finally, this project was successfully implemented with the cooperation of each member of the group as well as the help and advice provided by the lecturers of this subject. Finally, we hope that with the knowledge gained from this project, we will implement it in the future. So that's all from us, Group 5. So, thank you.